Standards identified in these activities have been adopted from the content standards of the national organization for each discipline. More information on this can be found in the Technology as Facilitator of Quality Education model. The students in this 8th grade science class are studying the properties of sound. A media specialist introduces the Artemis Digital Library, a database collection of World Wide Web resources developed by the University of Michigan. The students will use Artemis to find information on sound waves. This activity integrates Technology Performance Indicator number 8 for grades 9 through 12, which requires that students select and apply technology tools for research, information analysis, problem solving, and decision making in content learning.
Now, one of the things that I like about this search engine we're going to look at is that you can work as an individual on a project, but you could also work as a group. Say 4 people were working on the same experiment. If you looked at one of the websites that you liked, you could take a few notes and then you could save it to a folder that you create so that your other members in your group could share that same website, information in that website. Or people who are doing searches in the future from another school could look at your data folder and they would say, these guys have already done the work for me. I'm going to use their websites that they selected. So the goal here is to not spend all your time searching and looking through information. The goal is to get the information you need fast so you can spend the time designing your project and analyzing the data. See how we created a little driving question right here? I did that before I came to the class. All we would have to do is just, we can save our website to that. It's hard to see up here too. There's other buttons up here on Artemis where you. So what you would want to do is you want to save it. If you wanted to save it, and it'll go right into your folder. And if you want to share it, it'll ask you for a comment. You could enter a comment and say, people who are working in this group on animal communication, this would be a good site for you because it has more information on animals and animal hearing than human hearing. So that'll allow you to do both of those things.
The students search for information using Artemis. They will use the information they find to help them design experiments on sound. This activity incorporates Science Standard A1 for grades 5 through 8, which requires that students develop the abilities necessary to do scientific inquiry. The students use Artemis to help them identify questions that can be answered through scientific investigations.
I mean, here's a thought for an experiment for you, if you're thinking of something like that. Now, if that intrigues you, there are experiments that you can design to see. And you can try testing sound as it moves through the air, and then take the same thing and take that frequency and move it through liquid, and we have things to set up there, and then through a solid, and see what you notice. Okay? And the gas would be just as we do it right here. Okay? You wouldn't take someone's word for it. You would want to see if they're right or not, right? So that could be a suggestion you might want to tuck away. And by searching through these things, you'll come up with many other ideas based on what intrigues you with the information you find. And that's part of the reason why you also do these searches. Okay? As you get acquainted with information and read more, you can ask better questions.
During their search, the students have to find information on how sound travels. They discuss their findings with their classmates. The discussion helps the students develop their understanding of motions and forces. This addresses Science Standard B4 for grades 9 through 12.
How does sound travel? Tell me.
Okay. Can I start?
Yep.
Okay. Sound travels by movement. Without movement, you can't have sound. So what happens is an object moves, the waves hit the molecules, and the molecules move, and that's what creates the sound.
Okay. So we have movement of molecules, okay? So give me an example of molecules that would move in order to transmit sound. Bram?
Air molecules.
Okay, so now give me your other piece here.
Okay. Sound waves travel at certain speeds depending on the air temperature.
Okay, so air temp affects, right, sound travel, right?
As the students continue their discussion of how sound travels, they also develop their understanding of the interactions of energy and matter. This integrates Science Standard B6 for grades 9 through 12.
What is it about that arrangement that could affect the speed of sound that would make this make sense? Chris?
Since the sounds are arranged, the molecules are very close together. When they vibrate, they don't have to vibrate as much and is far away to hit the next one and transfer the energy. So it takes a lot less time.
Okay, great. So, if you take a look at the molecular arrangement in a solid, it's going to be very compact, right? And in a gas, it's very spread out. So, if sound gets from one place to another because it vibrates those molecules in that medium, it would make sense then that it would travel fastest through solids than it would through a gas. Where would liquids fit in?
Middle.
In the middle, okay.
The teacher introduces Sound Edit software. The software allows the students to explore how changes in frequency and amplitude affect sound waves. It helps them measure and record data from their experiments. The instructor implements Science Standard E1 for grades 5 through 8, which requires that students develop abilities of technological design. This activity also integrates Technology Performance Indicator number 4 for grades 6 through 8, which requires that students use content-specific tools, software, and simulations to support learning and research.
This here becomes a tool for you to be able to design an experiment where then you can have some real data that's collected, right? Not instead of, well, I set the meter at 50% and it sounded like it was 50%, but, I mean, was it? You know, this way, depending on what your printout is, and then you can print this in the back room on the printer, you actually have data that you've collected, the waves, to prove to us that indeed this material allowed sound to travel faster. This material didn't allow sound to travel as fast because you've got the actual data out here, okay?
And it works. No, it's 400. I write about it. And then for this thing, it's 100. That tone. Get away.
It makes the screen vibrate.
Oh god, we gotta try it. Try 800. What are you doing? You just find the tone. That's what we have to do.
So you have to go back.
Let's find the tone. Yes, find the tone. You remember where it was? It was in that folder. I don't know why it was in there, but it was.
Hey, do you have sound edit?